Confounds. Confounds are the dark demons of experimental design. They are often difficult to detect and can have large effects on results. The only way to deal with them is to be on the lookout. Confounds arise from extraneous variables. In an experiment, an extraneous variable is anything that varies other than the independent and dependent variables. There are loads of things that can vary in an experiment. Just think of all of the differences between the participants themselves. Some might be more willing to help than others. Some might have incredibly fast reaction times, and others could have exceptional memory. Researchers can't control these individual differences, so they use random assignment to ensure that the groups don't differ, even if the individuals in the groups differ a lot. Researchers must also be careful to keep testing conditions as similar as possible, so that differences in the environment don't have an impact on the behavior being measured. In their test of the power balance bracelet claims, Verdon and colleagues hypothesized that company tests showed positive results because of a possible order effect. Order effects in within subjects' designs can manifest as improvement in performance due to practice or an impairment due to fatigue. If control and experimental conditions are presented in the same order to everyone, it's impossible to disentangle the influence of the independent variable from the influence of the order of presentation. So the researchers tested balance, strength, and flexibility under 3 conditions: with a power balance bracelet, with a placebo bracelet with the hologram removed, and with no band. The results of the 2 control conditions were combined because the results were the same. By counterbalancing the order of the conditions, these researchers were able to disentangle the confound, and they found no support for the company's claims. Let's consider this hypothetical experiment looking at the effect of music on a cognitive task. The control group completed the task in silence, while the experimental group listened to music. What's the independent variable here? It's what was manipulated to create different conditions. In this case, it's whether participants heard music or silence during the memory task. But what's actually being manipulated here? Is it listening to music or not? Or is it silence compared to any other sound? The reason I chose this example is because of the Mozart effect, which was based on an experiment with a significant confound that went undetected by the researchers. Musical training has been associated with enhanced performance on many non-music-related tasks, so research has tried to uncover the mechanism behind this association. The act of playing music involves sensory, perceptual, cognitive, and motor abilities, so it's not surprising that musicians' skills in these domains get lots of practice and can be used for other tasks. Some argue that even the act of listening to music is associated with enhanced intelligence. One study asked this question with a simple within-subjects experiment, looking at performance on abstract spatial reasoning tasks taken from the Wechsler Adult IQ test. There were 3 conditions: silence, listening to recorded relaxation instructions, or listening to a Mozart sonata. The paper folding and cutting task shown here is one of the tests of abstract spatial reasoning they used. Participants choose the option that matches the folding sequence shown on the top. Do you know the correct answer? The 3 conditions are shown on the x-axis on the bottom, and score is shown on the y-axis on the left. Since these tests of abstract reasoning performance were taken from Wechsler's IQ test, they also express performance in IQ equivalents displayed on the right. Clearly, the music condition resulted in an improvement in performance on this type of task. Test yourself. Draw a basic flowchart of the experiment performed by Rauscher et al. 1993. In a follow-up article, researchers came up with a complicated explanation involving neuronal networks called trions that fire in specific patterns. They hypothesized that the spatial temporal properties of music interact with these existing trions to strengthen the network, which can be recruited for future spatial temporal tasks. In this study, they used a between subjects design and tested participants daily for 5 days, and included a mixed condition with different styles of music on each day. Again, they found an improvement on the paper folding and cutting task, although the silence group caught up a few days later after practice with the task. These two studies provided compelling evidence that listening to Mozart enhances performance on certain cognitive tasks. However, other researchers could not replicate these findings. One group of researchers were skeptical of these results and the author's interpretations, so they designed a mixed between subjects experiment. They also used silence and Mozart conditions, but added another group that listened to a different classical music piece, an Albinoni adagio. These researchers hypothesized that listening to Mozart could be altering performance by enhancing arousal or mood, rather than directly strengthening existing neural networks as proposed by previous researchers. In addition to the paper folding and cutting score, these researchers measured additional dependent variables. The Profile of Mood States, or POMS, is a 5-point self-report questionnaire. The researchers used the arousal and mood subscales to tap into these constructs. They also administered separate 7-point self-report items for subjective arousal and enjoyment of music. They replicated the Mozart effect, shown in the graph on the left, and showed that other classical music did not have the same performance-enhancing effect. However, the Mozart group also gave higher reports of arousal, mood, and enjoyment of music, as shown in the graph on the right. Previous research has shown that both mild arousal and positive mood can enhance cognitive performance, so the Mozart effect could easily be explained as a boost in mood that enhances performance. Test yourself. According to the results of the experiment by Thompson et al., 2001, what was a confound in the Mozart effect experiment by Rauscher et al., 1993? Unnoticed extraneous variables are sometimes confounds, which are a huge threat to the internal validity of an experiment. Careful consideration of intended experimental manipulation is key and often requires measurement of several manipulation checks.